Hi everyone, we're E4 Group 5. I'm Vi. This is Alyssa, that's Aaron and Kyle. And we're just going to talk about our design process for building the key sorting machine.
So our revised problem statement is design a method to sort key blocks by material composition and then length. So the changes we made from our original problem statement, the original was really long and detailed and had a lot of unnecessary information that wasn't necessary for what we were trying to build. And so we discarded the assumed solution of density sorting as well as replaced the word device with the word method so that we could use another method of sorting, as in like we could use sort by hand instead of using an actual machine. So our objectives and constraints, we chose our objectives based upon like to be accurate and to be quick, of course, because we want our machine to be accurate and quick and to like work when we put key blocks in. And to be safe, because safety is always very important. And to be portable and easy to make because of our limited time that we had to build the machine.
All right, so once we had our objectives and constraints defined, we came up with 6 different functions. Our functions were accepting inputs into our machine and then orienting those inputs, and then moving the blocks once they're oriented towards our sorters. And then we had measure and sort by length, and then determine material and then sort by material, and then finally storing and organizing blocks. For each of these functions, we came up with a number of different means to accomplish them, and you can see the highlighted ones here are our final means, and they came straight off of our morph chart.
So when we made our morph chart, we just threw up any idea that we thought of, but we wanted to narrow it down a little more, so we brought it down to 3 design alternatives for each of our functions so that we can discuss them more in depth, and we decided on that as a team. And we decided that to measure the length, we would use a PVC tube with lengthwise spaces to drop them in. And then to determine the material, we actually used 2 different designs. We used counterbalance bridges for the metal, and then we used water as a density determinant for the wood versus the plastic. And to move the blocks, we just took the simple method of PVC tubing. And to store the organized blocks, we had them fall into buckets. We didn't actually have a method of accepting inputs due to time constraints. We just put them in by hand. And also we oriented the inputs by using a half pipe.
So before we actually selected one of the design alternatives to implement, we wanted to see which of our objectives we considered more important. So as you can see, our 6 objectives are lined up both in rows and columns, and we basically did a pairwise comparison between all of the objectives to determine which ones were most significant. So we can see here the top 3 are be safe, and then be accurate and be easy to make. And the rest were kind of secondary to those primary needs for our design.
Here we can see that we separated our designs based on function. So we have like 2 different designs to sort length and 3 different designs for mass. And we decided on design number 1 for each of the functions because these fit our objectives and met them the best. So for example, the design for the PVC fit or was better than the wood with the holes for sorting length, and it met our objectives better. Even though we found that the mass sorting had the same scores, we decided on the first one based upon the piecewise comparison chart that we saw in the last slide.
So once we determined each of the components of our design, we then we started our building process. And the first half of our building process was to test the individual components of our design just to make sure they worked, and putting them together would be a viable method of solving the problem. After we determined that our methods would work, we drew a 2-scale diagram for both components together so that we could see how they would fit together and have the dimensions correct so that we could separate the tasks. As you can see, the design that we drew was on the right side. Once we drew the diagram, we then divided the work based on function to make the process more efficient. For example, one person took care of the length sorting while another person took care of the mass sorting. And once all the parts were built, we then assembled the components together and then tested and calibrated to make the adjustments to make sure our final product would work as we expected.
As Vi was just saying, we began our testing process by building a couple prototypes of pieces of our design to make sure everything would work. The first thing we built was a prototype of the PVC length sorter, just to determine whether or not we'd be able to do it. We also used that piece to decide what hole size and what angle we were going to use to make sure everything would work when we put it together. We also tested the counterbalances to make sure we had the right weights and that they would swing and sort by mass. Once we actually built the device, we did a lot of testing with the key blocks, and we actually added a couple things. We put guiders on all the ramps to make sure all the blocks would go into the buckets, and we also added nets to the buckets, little drawstring nets, so we could pull the wood out because we realized that extracting the blocks was kind of messy. So overall, once we got everything together, our machine worked pretty well with the occasional stop in the pipe or a little jam on the ramp. But other than that, it worked very well. We had some problems with blocks that were too wet and had expanded and didn't fit in the pipe, but everything worked when it was dry.
So this entire project was really a learning process. So while we were building our machine, we came up with a couple improvements that we could implement had we had more time and or more resources. So possibly, as Kyle mentioned, we did have problems with the wood expanding when it was wet. So a wider diameter of tube would have fixed that problem without compromising the length sorting mechanism that we had wanted. Secondary was the counterbalances that we used to sort the metal but not the plastic and the wood because it was too fine of a difference. Had we had more time, I think we could have calibrated those to a much finer degree and thus improved our mass sorting device. Then we also ran into some problems with the key blocks kind of going off the ramp and not really into the buckets they were designated for. So that could be fixed by two things. One, more guiders, just so they would follow a more specific pathway, as well as a material that was less friction deemed, I guess. And then finally, we wanted to fix the input method. So on the actual day of our presentation, we used it by hand, but if we wanted to improve our design, I think we could have used pour them all into a box, and then the actual machine would sort them, orient them, and then feed them into the sorting devices.
All right, so this whole design process was a learning experience for all of us. Some of the key things that we learned were that proper planning is really important. If you have everything planned out before you go to build, everything works a lot better. Also, a lot of testing before building everything will help you make sure every little piece will work when you put it all together. We also learned that even if you do a lot of planning, once you put everything together, there are often extra variables you didn't account for, so it's often required that you make small adjustments like we did after it's built.
So we would like to acknowledge a couple people. Firstly, we would like to thank our profs for helping us and really guiding us through this whole process, as well as the shop proctors who were there over the weekend while we were there trying to slave away on our project and really there to support us and help us when we were in need. So thank you to everyone that was involved.
Thanks for watching, guys.